Hi, I'm Sandra Occhipinti. I'm the Research Director of the Discovery Program at CSIRO. And today I was going to talk to you about mineral systems of the Capricorn origin through time and how we use geophysics to kind of interpret the region and get us through that mineral systems analysis. But in 10 minutes, I can't do that completely. So I'm just going to give you a snapshot of what we've done and point you into the right direction as to where you can find the data that we use and actually run your own prospectivity models from our analysis. Okay, so this work was completed as part of the Capricorn Distal Footprint Study, which took place between about 2013 and 2018. And it really still does continue because we're still writing everything up and publishing all of the work. It was a collaborative effort between Curtin University, the University of Western Australia, CSIRO, GSWA and mineral exploration companies, and was funded generously by CEF and Mariwa. So mineral systems through time, this is how we put together or planned our mineral systems analysis for the area. We completed a time-space correlation chart for the region, but this is more of a geodynamics type chart than a rock types chart, if you like. And these grey areas in here, and I'm just going to find my pointer, these grey areas are here. These represent when mineral systems may have been forming through the region and what sorts of deposits may have formed. Okay, so we're really interested in the times between about 2,400 million years and right up until recent time, in fact. This chart only goes to 1560 million years. However, we also did map for superficial deposits as part of our analysis in the region. You can find the prospectivity models and all of the data that went into making those models on the CSIRO Data Access Portal. You just Google it essentially and you'll be pointed to this page and you can download that GIS with all the information that you need. Okay, so the Capricorn origin. The Capricorn origin lies between the Aitken Pilbara up in here and Yilgarn cratons. It contains the Glenburgh terrain, which also contains Aitken, which essentially underlies a lot of the Gascoyne complex up through here. It formed, it was a two-stage development of the Capricorn origin. Basically, it developed when the Glenburgh terrain first collided with the Pilbara, and then they both collided with the Yilgarn craton. And that sort of process, two-stage process, occurred between about 2200 for the first collision and between about 2000 and 1950 for that Glenburgh orogeny in the south through here. Now, as part of this analysis, we had to take all of that sort of the tectonic development into account. And that was a tectonic development that developed the West Australian craton, which is this whole region through here, but also everything that occurred post that. So all of the reworking that occurred in the region post that. So in the Capricorn origin, basins developed between the Proterozoic, Paleoproterozoic and Neoproterozoic, some of them before the West Australian craton was formed, like this area down here, the Ureta Basin. There were sites of subduction and accretion, as I've just told you, and lots of felsic and mafic magmatism. As part of the mineral systems analysis, we need to map for deep crustal-scale structures. We primarily used gravity data for this in the region, but we also use seismic reflection data, some passive seismic data, and also some magnetotellurics data. But here's an example of some deep crustal-scale faults believed to be Archean, separating mainly Archean terrains that underlie the basins within the region. Here they are again on the left-hand side, but at a smaller, shallower scale, if you like, so further up in the crust, we use magnetics mainly to derive our structural information. And this structural information, some of these faults will be deep crustal scale faults and basin forming faults perhaps, and some faults are simply part of fold and thrust belts as they form through that region. But they could also be very important because they could be depositional sites of mineralisation, so we have to map all of those. We also reprocess remote sensing data for the whole region. Here's just some examples: a ternary radiometric image, obviously SRTM, the Landsat TM image here, 742 image, and also an MGO ASTA image here. And all of these data were used in the analyses. Geochem data from the region. So the region is mostly covered by 4 kilometre space regolith geochemistry, which was collected by the Geological Survey of Western Australia over many years throughout that region. And also there's quite a lot of hydrogeochemistry now. Of course, we're limited to where we can get water in the area, and mainly where there are bores. So there are many areas, parts of the Capricorn Origin that really don't contain bores or are fairly inaccessible. But so both types of data were also used in the analyses. We could also have a think about of using sulfur data, and we did use sulfur data in the analyses as well. So essentially what this sulfur data was collected as part of the Capricorn distal footprint study by Crustal-scale, Marco Fiorentini and others. And you can see here that there's a difference in the sulfur isotopes throughout the region, and that is essentially reflecting, in this case, the influence of Archean crust on the Proterozoic in that region. Also, so as part of this study, even though there were there's really good geological maps and solid geology throughout that region that you can download from the GSWA website, we had to essentially go back into those maps and extract our fertility elements for our mineral systems analysis. It's not always easy, but we were looking for particular rock types, and we had to extract those out, and from using the remote sensing data, also some mapping throughout the region. So here's just some examples of areas where we did that. So the part of the Irahidi Basin, the Ureta Basin, we did quite a lot of work in the Ureta Basin to extract out the particular lithologies from throughout that basin for our analyses, and the Ashburton and Bresnahan Basin. Of course, we also did it for the Ebb and Collier Basins, but I'm not going to show you a figure here, but you can get all this information in the GIS. All right, so we had to, as I was saying, we have to extract those critical elements out so that we can combine them in our prospectivity model and get some ideas in terms of where areas are prospective for what, basically. So here's some critical element maps of deep crustal-scale structures. Here in the middle, this is the Ureta and Irahidi Basin areas. You can see these are these Archean structures coming up underneath the basin, so they were extracted. Here are some younger structures through here, probably Proterozoic, and through here as well, through the Yarraville Ice Complex and the Bry Basin in here. And this area up in here is that area in there. For the Ashburton-Bresnahan Basin area, so Bresnahan Basin is down in here, and the rest is essentially Ashburton Basin. The deep crustal-scale structures are mainly southeast trending, but there are also some northwest trending ones as well. And here's just a couple of examples of some prospectivity models. We must have run about 20 different prospectivity models for the different areas. And again, they're available in that GIS. So for the Ashburton-Bresnahan area over here, so in the northern part of the Capricorn, a prospectivity model for gold, and it did agree quite nicely with where we do know some gold deposits are. These are not all mines, by the way. These are just deposits. And the same for the Ureta region. You can see it's mainly in the northern part that we think that the area is prospective for gold. And continuing for the Edmund Collier, on the left here you can see base metals prospectivity, and we did find these were in agreement, the areas that we thought were prospective with known base metal occurrences. And just a comparison here between GA's analysis for nickel copper PGEs in the Ureta Irahidi region and ours. we didn't find the area to be very prospective for PGEs, and it's just the data that we've used compared to what GA have used. We've probably been a little bit more granular in that data that we've used. They've done just a more regional look at that region. Okay, so I'm at time. So this is us. We are a diverse and very inclusive group in the Discovery program. We're a cohort fueled by EMCR enthusiasm and guided by experience, supporting everybody, not just a few, so that everyone can achieve the best that they can. Thank you very much.